Hello. I introduced the normal distribution briefly in the previous video. So the bell curve is like it's commonly found in many places. Now we are going to study more important and more practical aspects of the normal distribution. So from now on, the reason why the normal distribution is important is because all the random variables in this course will be approximated to a normal distribution. This is the power of the normal distribution, right? Then, however, but the problem here is the bell curve looks nice, but what we had to do with the bell curve is to calculate the area below the bell curve because it is the probability density which is devised to understand the probability as an area. So we have to calculate the area, but it's not a straight line. So the shape under the curve is not simple, like not rectangle or like triangle or any shape we know how to calculate the area. So it requires integration, but even if you know how to integrate, it's not easy. So you cannot calculate the exact probability by hands. Therefore, we have to use a computer or other tools. What complicates the problem even more is the parameters. So if you have different parameters, then the bell curve will change. Then you have to recalculate the area. The probability will be different for different values of parameters. Therefore, again, you need a computer. Computer can do it easily. So I will show you how to handle this. And when you actually calculate the probability, the CDF is better than the PDF because from PDF to probability is an integration. But if you know the CDF, then probability is more like easily calculated. That's one solution to that difficulty. And another solution, and the second way to handle the second problem is that we are going to fix the parameters at 0 and 1. So different parameters will yield different probabilities, but for a while, I'm going to consider these standard values, 0 and 1, simplest possible values. So we are going to call this normal distribution as the standard normal distribution. This is the standard, right? So the mean is centered around 0, and the variability is standardized to 1. And then this is also very, very commonly used standardization. So it has its own notation. Usually Z in statistics is reserved for standard normal distribution. Standard normal distribution, so Z is the random variable that represents a normal distribution with parameters 0 and 1. So using the standard normal distribution, we would not worry about the parameters for a while. Later, I will tell you how to handle them, and also the bell curve, calculating the area under the bell curve is not easy. So we are going to use the CDF. Then where is the CDF? How do we get the CDF? In the past, when I was a student, I like the professor distributed a paper with a lot of numbers. That's distribution table. So I will show you. If you search probability standard normal distribution table, so it is a table, then you will see something like this. There are a lot of images. All are the same table. So just bunch of numbers. What are these? These are the values of CDF. So if you input specific number, then you have to find the corresponding value. This is how I learned. Or there is a PDF file. It doesn't matter which one you use. They must be the same. So it's like a bunch of numbers. It gives probabilities to you. And before the pandemic, I used to use this table in the classroom because there is no other option. Otherwise, students had to bring their computers, laptops, or tablets, or that they can use Excel or some scientific calculator. That's not easy. And I know some students may not have them. I cannot buy a laptop for them. So I had to use this normal distribution table, but now you are not restricted to a paper form. So a better way is obviously using Excel. You do not need to use paper when a better option, computer, is available. So I'll show you how to calculate CDF. Let's think about this first. So remember, the CDF, cumulative distribution function, is defined this way. When you specify a value A, then this function returns probability that a standard normal random variable is smaller than or equal to that value A, right? So given A, input A, then returns probability smaller than A. That is the CDF, and I am going to show you how to find the standard normal CDF at these values. I will just show you how to find probability standard normal smaller than -2. Standard normal probability smaller than -1, 0, 1, 2. So I will show you. You use formula, go to formulas, and insert function. And here type norm. Then it shows many functions that's variations of normal distributions. I'm going to use norm.s.dist. This is normal distribution, normal standard distribution. So this is standard normal distribution. So click this. Then what you have to specify is z value. This is the value you are calculating, -2. And cumulative, yes, we are using the cumulative distribution. So enter, then you get this. This is the probability. So I will. So value was -2. So probability smaller than -2 is 0.02275, which is 2%, approximately 2%, more precisely 2.275%. Of course, if you increase the decimal places, you can get arbitrarily more accurate. So, but I'm going to cut this at say 2275. And similarly, I will evaluate. So this is cumulative distribution. So given a value, I calculated the cumulative distribution. I will do the same thing. I will type the formula. Equality equals normal standard distribution and -1 true, which returns another probability 0.15866 blah 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 blah, which is this probability 15.86553%. So this is the probability smaller than -1. In a similar way, we can calculate all the probabilities. It's also expected that probability smaller than 0 is 50%, which is obvious because it's symmetric about 0. So it's symmetric on the positive side and negative side are symmetric. So smaller than 0 has 50%, greater than 0 has the other 50%. So it should be 50%. And in that way, you can calculate cumulative distribution. It does not matter what you use. So let's try a strange number, say minus 100. What do you expect? Probability smaller than minus 100 is 0. So minus 100 is a very, very small number in the scale of normal distribution. So its probability is 0%. Nearly 0%. If you put more zeros, then you may see non-zero, but approximately 0. Or alternatively then, let's try something else. I will choose any number, 33. I just choose an arbitrary number. If you calculate probability smaller than 33, it is 1, which means 100%. Because 33 is large enough, so probability smaller than 33 contains almost all the possibilities. Usually, a rule of thumb is, in this table, the smallest number is 3.9 up to the largest number 3.9. So rule of thumb is plus minus 4 contains almost all the probabilities. I'll show you. Say normal distribution, standard normal distribution. What is the probability smaller than minus 4? This small number, which is, let me put it this way. So only 0.0031% is below minus 4. So plus minus 4 or plus minus 5 is it contains almost all the possibilities. So I want you to have just a sense of the scale, the range. And I will show you, I will also demonstrate what happens if you, so here, you had to choose true or false, but when you input true, you get cumulative distribution. When you input false, you will get density. You will get density, so it is the density, but it has no direct meaning. So density itself doesn't mean anything, but you need to calculate the area. So density can be calculated, but you cannot interpret this as a percentage. It doesn't imply 5% because it's not a probability itself. You have to calculate area. Before calculating area, it does not have probability interpretation, right? So again, to summarize, we want to calculate the probability of the standard normal distribution. Then how do we calculate that? It's not easy to do that by hand, so we are going to use Excel. I will use Excel again and again, and in the homework you will use Excel again. And if you have like, so for example, if you want to use standard normal probability, like say calculator, there may be other like resources you may use, and if you know how to use that, so for example, I don't know what it is, so if you want to use this, that's also fine. But I guess there will be little difference. It doesn't matter which resources you use, but you should be able to calculate the probability. And I will assume that you use this approach. This is what I recommend, and this is the most standard way to calculate the normal probability. And we are going to use this method again in the later chapters. As I said, all the random variables from now on will be approximated to a normal distribution, then every time you calculate their probability, you are going to use this one, this method. So it requires some exercises to get used to it, and also the practice will help you in the future. Later, at some point in your career, you will encounter normal distribution again, right? Then this will help. So believe me, and I will give you some exercises in the next video. Okay, see you there. Bye.